equation that models exponential growth or exponential decay. At the beginning of the environmental study, a forest covered an area of 1,500 square kilometers. Since then, this area has decreased by 8.75% per year. Let T be the number of years since the start of the study. Let Y be the area that covers let Y be the area that the forest covers in square kilometers. Write an exponential function showing the relationship between Y and T. The first thing we want to do here is recognize Y is a function of time. So instead of using the letter Y, why don't we change that to Y of T? So here, make sure we use Y of T. We're going to go ahead and use function notation. The next thing we want to do is actually find a pattern. Well, we know at the end of the first year, we no longer have 1,500 square kilometers. In fact, we lost what? We lost 8.75%. So how much of the original forest do we have? Over here, let's write a little bit of a thinking bubble. And why don't we take 100% and take away the 8.75%. And what do we get? We get 0.9125. The decimal of 0.9125. So after 1 year, when T is 1 year, how much forest do we get? Well, we get Y of 1 is now equal to decimal 9125 of 1,500. What do you think happens when 2 years go by? Well, when 2 years go by, that means we're going to have Y of 2, the input of 2. Well, we just take the previous line which is that, and we now multiply it by another what? 9125. So this really is what? The initial amount of the forest multiplied by decimal 9125 raised to the second power. So what would be the pattern when T equals 3? Well, you get Y of 3 is now equal to, you take the previous line and once again take what? 91.25% of it. So we get 1,500 again, and this time we multiply by 91.25% of it, but raised to the third power. Can we generalize this for T? Of course we can. I'm going to write 3 dots here. And let's get to our Y of T function. Our Y of T function must be what? We must have the initial amount of the forest, which is 1,500 square kilometers, and then we'll simply multiply that by some portion depending on the number of years that elapse. So in this case, we would just put T as an exponent. Notice this. Notice that the base, decimal 9125, is less than 1. And what kind of model do we have then when you know the base is less than 1? This is going to be exponential decay, which means that the amount of forest is actually decreasing. And so the mathematical model is actually indicating that. Why don't we circle our answer?